Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. Ajay Kumar and he will talk about smart solar tree and air water generator for agriculture purposes. I now request the speaker to begin. Thank you.
Hi, good evening, everybody. My name is Ajay Kumar Khanna, and I'm the Chief Technology Officer of Titlis Engineering and Projects Private Limited, based in Vadodara. And we have some very innovative concepts related to renewable energy, which can be highly useful in present days as well as in the future for utilizing into the agriculture sector. So one of our basically a benchmark product is a smart solar tree, for which I will just take you here. This is the one of the these are the type of different designs of the smart solar trees, which we have designed and installed in several places in India, including some of the corporates and government offices like ONGC and Coal India, Unilever factories, as well as in the smart city Bareilly. So these are the type of designs. There are many more other designs which can be customized as per the location and as per the overall power requirement. Initially, this solar tree was actually developed for the purpose of supporting the street lighting and the surrounding lightings in the compounds, so that from one place the larger area can be illuminated. But later on, we integrated many more features in this solar trees, like CCTV camera is installed in this now. There is also an EV charging systems can be activated using solar power. And then there are different type of lightings and sitting arrangements. Also, a water filter can be integrated within this solar tree using solar power. So the people who comes to the common place, or maybe the places like in the parks and or in the corporate houses, when they come and possibly sit around the solar tree, they will have most of the facilities available to work and act, or to relax. Also, there's a opportunity. Also, there's a possibility to integrate a music system as well as Wi-Fi in this, which we have done in the Smart City Bareilly project, which is this one currently. This is the Smart City Bareilly project. It was installed about three years back, and six of them were installed into different campuses in Bareilly, and then all of them are still running smoothly, and all the features are still activated there. Now this one, which you see on the right side, where we have also integrated a small micro wind turbine. And if you can see this one here, and then this micro wind turbine is an additional support system for keep generating power even when there is a rain or there is no sunlight. So this is basically an hybrid wind solar tree, which is more beneficial because it can continue to generate energy even in the night or even in the cloudy days. So the battery backup or the power requirement is always available even when there is no great power available in the city or in the area. So this is something which is more beneficial possibly even for the agriculture purpose, because this will give a 24/7 power supply to the farmers for the irrigation purpose and for the cultivation purpose. This can, these solar trees and hybrid wind solar trees can be designed from 1 kilowatt to 10 kilowatt capacity, because beyond 10 kilowatt capacity, it is quite challenging in certain locations in the coastal area or where the wind velocities are much higher. So the most suitable designs we still prefer remain under 10 kilowatt, which is sufficient to feed and support majority of the agriculture requirement. And if there are more pumping requirement or more irrigation requirement required in the field, uh, one or instead of one or two solar trees can be installed, which can possibly run two or three parallel solar pumps for the irrigation purpose. So this is something which can be adopted for multiple applications. Now, assuming no, you can install this into expressway or highways, and it can one of the 10 kilowatt solar tree can illuminate up to 100 street light. So the maintenance becomes very easy because you have to only maintain one solar tree or one hybrid wind solar tree, and instead of maintaining 100 street lights. So this is something which can be highly efficient in operation, as well as saving cost in the maintenance and time in the maintenance. And that's how it has been projected already. And some of the smart city, it is being planned already to install into the street to support the street light as well as the signal, the traffic lights. And apart from that application in the other purposes, agriculture is one of the big purpose, definitely, because these days the farming is becoming more tech farming. People are adopting hydroponic system, adopting vertical farming, and primarily vertical farming, can use this type of power arrangement because for utilizing for activating their blowers, activating their sprinkler systems, and also if it is highly automated or mechanized system in the vertical farming, the power can also be used for the spreading and cutting the crops and other purpose. Otherwise, along with the solar tree, we are also having a very innovative product, which we did not actually discuss yet. That product is the any question in between. Possibly you can park for the end where we can respond. So along with the solar tree, now solar tree actually was not in the picture until 2015 in India, and 2015 we were the first to launch a 3 kilowatt solar tree for an army base in Secunderabad, and that was the first time in India the solar tree was actually initiated, and concept was demonstrated successfully in a large exhibition in Mumbai, and demonstration running trial and demonstration in army base in Secunderabad. After that, this concept has been picked up by many of the innovators, and as well as many of the energy companies. And now it is part of the several tenders and smart cities everywhere, as well as there are several tenders by the corporates to design and install a designer solar tree, or as per their power requirement or for the aesthetic values. Solar tree has a features like it only occupies about 4 square feet of space in the ground on a concrete base, and about 15 to 16 square feet space on the air, which is around 15 to 20 feet high from the ground level. So that occupies very little space and can be accommodated or installed in any place basically you think of. And when this is something which have inbuilt category or integrations of sun tracking system can be integrated in this for the higher efficiency. In some places where the sun exposure is limited, the tracking facility helps to obtain the maximum efficiency of the solar tree. As compared to the traditional rooftop solar system, solar tree generates around 40 to 45% more energy on a daily basis. So when a normal rooftop solar system generate a 4 unit 4 kilo kVA per kilowatt of the solar system. But here in the solar tree, we can generate almost 6 unit per kilowatt of solar capacity. So that gives you an additional capacity, definitely, and saving space. Some of the benefits, I think I will share you the type of benefits which you have. It reduces definitely when you have more of the solar trees and integrated wind solar trees, your you are basically contributing a renewable energy, reducing the fossil fuel and reducing the pollutions in the surroundings. It needed much lesser space. Definitely, I briefed certainly. Initially, it had a capability to generate 30-35% more energy than the sun rooftop system. But today, it is around 45%. Because of the enhancement in the solar modules capacity, solar module efficiency, and this is something like it has, and it can also be used, in a public places like we can integrate the water spray nozzles, something which can be used for actually giving the cooling impact to the people who are in the surroundings, as well as it can reduce or it can absorb the smog or dust to reduce the pollution in the surroundings. If we suppose, imagine if we install possibly hundreds of the solar trees in the street of Delhi or NCR or Gurgaon, possibly a substantial reduction in the smog or dust is possible to achieve, and that will help the citizens to breathe properly and breathe better than the today's situation. These are the features basically for the solar tree. And then when you have solar tree also used for the gadget charging these days, EV charging. If you have a 10 kilowatt solar, you can actually charge 2 or 3 small vehicles like two-wheelers or three-wheelers without any issues from this facility. And you can also charge your mobile, your other things while sitting for 15 minutes, 20 minutes. These facilities are available normally by the public places. Apart from the solar tree, we also have a very innovative, basically air water generator, which is actually producing water from the mist or the moisture available in the air, which is called atmospheric air. Now, this is a concept highly used, widely used in the Middle East, especially in Israel, who is mastered the production of water from the atmospheric air. So this is some technology is not something which is new. It is actually running there for last 15 years in Israel, but in India we have actually modified and upgraded this technology. The earlier technology for producing water from atmospheric air was a single stage water air absorptions and then cooling it down to convert into potable water. We have upgraded this technology to multi-stage air filtration and conversion into the water. So this gives us another 30-35% more water using same amount of energy which is used in the traditional process. So this becomes quite useful. Like we have already designed and installed 200 liters per day system and 1000 liters per day system. And now we are working to design around 5000 liters per day system using this solar and wind integrated technology. But that would be highly useful again for the agriculture purpose. Primarily, when you have a 5000 liter per day generation system, it can be stored to a larger volume, or it can also be used directly into the tech farming in the hydroponic farming, polyhouse farming, and vertical farming, which needs very little water as compared to traditional water consumption in the agriculture. Normally, the traditional agriculture needs around, suppose in 1 acre, they need around 10,000 liters of water. In the tech farming or vertical farming, you only need 10% of that. So if you need only 10% of the traditional farming, a 5,000 liters per day system can actually irrigate close to 5 acre of vertical farms, which is a substantial volume for producing your agriculture with your vegetables and fruits into the controlled environment in polyhouse and vertical farming. That gives another advantage actually in vertical farming is actually generates 3 to 4 times more output being vertical in the design. And so your 1 acre actually can generate up to 4 acre of product, vegetables and fruits. So just imagine like your 1,000 liter system of air water generator can actually can irrigate up to 4 acre of output when you are producing the vegetables and fruits in controlled condition under vertical farming. So this is something which is not yet commercialized in a large way in India, but it is being picked up by many of the entrepreneurs. And I think in next coming 1 or 2 years, the vertical farming could be one of the major concept to produce our food and bridge the gap. In the today's world, uh, like uh, we will be close to 9 billion people by 2035, and our soil performance has reduced to 50% in last 40 years. It means today we are only producing up to 7 billion people. Uh, by 2035, our soil will be only able to produce up to 4 billion people. So you will need possibly an additional food security. You'll need a higher output food production by means of technology, which will help to feed additional 2 billion people plus 3 billion of the backlog people. So this is something which is being picked up already in the Middle East market in a big way. Half of the Israel production is in the vertical farms. Everybody knows that, and several of the Middle East countries have started adopting this concept using no using less water, and then using vertical farms to optimize the output of the vegetables and fruits and other activities in the food market. So this is something. This is a concept which was really we modified it and upgraded it in 2022. We 21 actually we collaborating with the IIT BHU. We actually launched this and installed a smaller version in one of the Coal India sites in Singrauli, and also the 1,000 liter system also installed in the same place. Now we are working on a 5,000 liter per day system. Hopefully in coming few months, we should be trialing a 5,000 liter per day system using around 20 kilowatt of solar power and wind power. So that will be able to generate our water at less than 50 paisa per liter. And the same water actually with a little tweaking can also be used for drinking. So it is highly advantageous technology for the all of the coastal belt, where you have a lot of water but can't drink directly, but also can be used in the some of those arid areas where no seashore or no coastal belt, but still population is there and they need the water definitely. So this can be used highly effectively in the African countries where every 1 in every 5 child dies because of the poor quality of water. So this concept is really highly useful for life saving as well as for the irrigation purpose in increasing the productivity and yield of the agriculture products, and at a very minimum cost. Although this system, making a 5,000 liter per day system at this stage could be expensive, but when it is adopted in a larger number, it will be very competitive, and price of the cost of the water production will come down further. So that will give an opportunity to the a cluster of farmers or the cooperative of farmers to possibly buy 1 or 2 units or 4 units for a average of 40, 50 farmers or 100 farmers. And also some of the companies can actually set up this type of system and lease them and charge a little amount and offer these services to the farmers. So the farmers will not have a burden of investing any large amount into the capitals. So that's type of concept. That was the concept to design this system, so that more and more farmers can be benefited by utilizing this, and also the people who are actually having less access of the water or arid areas, people can also embark into the agriculture production in a systematic way or in a tech way. So that's something which is now being visualized by many of the institute as well, and many of the corporates are, we have been discussing to commercialize this in a large way, and that will be definitely highly useful for country as well as globally. Because people in Africa still struggle. I have seen, I've been there for a few years, worked while working with the global companies. I have seen their challenges. I have seen also the Indian arid areas challenges, where many of the kettles die in the summertime without having water. So this could also actually save lives of the people as well as lives of the kettles anywhere in the world, because water is the most important factor for living for anybody, actually. Not only for producing the agriculture product, but then also for the life. So this is the type of concept. If we can commercialize in a different capacity of 1,000 liter, 5,000, 2,000 liter, 3,000 liter, maybe 5,000 liter per day, and that will give a lot of flexibility to the people to adopt. Like if you heard, you're in the south, in Chennai 2 years, 3 years back, there was no water for drinking, and half of the corporate offices there have instructed their employees to work from home, as there was no water to manage their corporate offices and all day-to-day activity. So this is that I think IIT Chennai also has developed something similar, and they have been already running this in one of the same campus, and also they have supplied a few of them. But again, they are all single stage. Our concept is multi-stage application, so that we generate more water at a lower cost of energy. So that's the advantage we carry, and that is what we want to populate, so that it should be available to affordable to everybody. So these are the two different products we have been able to. We have more products definitely. So the concept is that when you have concept of how the water is being produced, actually is. So when we have the water, see hot atmospheric air actually. So we have a system. We have multi-stage filtration where the air is passed through. We have a blower which will actually suck the air from the atmosphere, and after filtration, it will basically pass through a desiccant based system, which will actually absorb certain moisture, and then it will go to the next stage of the condensing coil, and then where it will be condensed to the water. So that will actually be then again pass through the activated carbon filter and other filtration process to have the drinking water. But then if we want to use only for the agriculture purpose, we can reduce the number of filters, but still produce the water and use for the agriculture purpose. So it has both possibilities. Like we can design one for the agriculture purpose and one for the potable water purpose. There could be a minor cost difference basically in filtration system, but both options are option will be offered to the people in the market, so that people can choose as per their requirement. No, the people in the urban area will pick up possibly more of the drinking water, and people in the rural area will pick up more of the agriculture concept, water at a lower cost. So this is the type of advantage the product will carry. So that's all thing. We have two of these product, very innovative product. We have been working with several institute for developing other products also. So we work closely with the Defense Institute in Pune to we're trying to create a solar calendar basically, which could be used as a curtain and room to room, so that you can customize your power instead in a bigger cities like that, like a multi-story building, high-rise building have very little space for actually installing solar. So the solar calendar and solar windows can be adopted by the large cities for the high-rise buildings, which can be used for the power generation and still save their money. So these are the products we have been already developing now, and some of these customers, I think we have already installed uh, some of the several of these products, like the air water generator and solar tree, are quite large number. But then other products which we are developing, these are our global clients. Firstly, they adopt it globally. We have received some of the accolades, rewards, and all in different exhibitions. Not all have been put here, but 2 or 3 of them. So this is where I think we have a very innovative concept, and we have been working primarily for innovative product which India do not have, and or India has limitations in developing. So we have tried now. This is another product I think which is highly useful and import substitute, and it's a robotic based solar module cleaning system of our company, which can clean up to 1 megawatt or 5,000 modules per day. It has a very innovative concept of collecting the dust instead of blowing off the dust. So we can collect the dust and possibly dispose of properly without disturbing the environment further. Most of the system are available normally globally are basically they will have the scrubbing system and blow off the dust settled on the panel and the modules surface, and then it will still pollute the surroundings. But we have an integrated system of vacuum system to absorb. After scrubbing, we absorb the dust or coal dust so that the environment actually is not affected by our cleaning, and the modules and solar parks are cleaned properly. So this is something which is automatic system. It can be used in the dry mode, it can be used in the wet mode, and it can be pre-programmed to use in the dry and wet mode alternatively. It only needs one person to manage the whole system instead of 50, 100 people doing it, cleaning the solar parks manually. So it also saves the cost to the contracting companies, operation and maintenance companies, and it saves the environment definitely. And by cleaning it regularly on a pre-program mode, the efficiency of the solar modules is maintained. Otherwise, we lose around 16 to 17% energy every day. Assuming 100 megawatt plant losing 16 to 17 megawatt every day by not having proper cleaning is the big loss to the installer, big loss to the nation. So these are the type of product we have been developing. Many other concepts there we have been working on. Definitely, we're trying to make a solar pyramid now, which will actually give a large amount of solar power in a limited space. Now at this stage, you need about 4 acres of land for a 1 megawatt solar power. We have been trying to reduce 1 megawatt for 1 acre, 1.5 acre. So that will save a lot of space for the people and for the country. And in a smaller space also, the large amount of solar system can be installed. That's all from my side. If anybody have any question, please come forward.
Thank you very much, sir, for your presentation. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir, so that we can see a full video?
Okay, we can stop that.
Yeah, stop sharing the screen, sir.
Okay. Thank you.
I'll take up the questions now, sir. What are the key engineering challenges in designing a solar tree that can withstand rural field conditions like heat, dust, and uneven terrains?
Okay, yeah. So the solar tree basically is concept is designed to feed the centralized power to the far distances, and also it can the first of all design point of view, like if you can set up this in a one single location in a very little space of 4 square feet, and then you can actually use this same power to the whole of the campus or to the surroundings. Maybe you can feed to the different applications as well. Like people are using solar power with solar tree for running their air conditioner. So they are running their offices. They're also using this for the illuminating the community center, as well as they're running the solar pumps. So this has a multiple application in different locations and different situations. Cleaning point of view, like solar panels, at this stage, solar tree, we have not installed an automatic cleaning system, but we have the sprinkler system. Instead of, because it's such a small system, putting up an automatic system will need a lot of maneuvering, and cost of the tree will become much larger. So we have put up the water sprinkler system, which will basically again a programmed sprinkler, so it can clean once in a week type of duration for 10 minutes, 15 minutes. and that will be sufficient for cleaning objective. And water sprinkler can take the water from the any of the surrounding supply. And there is also an alternative arrangement to keep a small water storage system, which can take, because it does not need a large amount of water to clean one 5 kilowatt solar tree. Primarily, which is the major capacity installed throughout the country, is a 5 kilowatt size. So 5 kilowatt size will have around 10 or 12 solar module at this stage in today's capacity range, and it can actually need around 40 to 50 liters of water every time you need a cleaning. So without putting up a manual man and on top of the 15 feet height or 20 feet height, it is better to have the water sprinkler system integrated while designing stage. So we have designed that way so that people don't have to worry about the manual cleaning.
Okay. I'll take up the next question, sir. How can farmers practically use the electricity generated by smart solar tree on their field? Is it suitable for powering irrigation pumps, cold storage, or other agri devices, sir?
Yes, of course. So when we're talking about solar tree, right now there's already a solar pump available, which is actually using a solar array, using solar modules to drive a smaller size pump of 3 kilowatt or 5 kilowatt or 10, this type of size of the pump already done. But if you want to run more pumps or higher capacity pumps, we can actually install one large 10 kilowatt solar tree and run 2 to 3 pumps at a time in a surrounding area. Like the farming people don't have their farms 10 farms by a single owner. Possibly every farm is owned, every land is owned by one person, and then every person is not capable of buying a solar pump. So if we have one solar pump, actually solar tree installed, it can actually offer the pumping possibilities to 2, 3, 4 neighboring farmers also, which can be given on a goodwill basis as well as it can be given on a small chargeable basis. So the person who cannot invest in a solar pump can also get benefited from one installation done by someone, at least one of the farmer. No? So this advantage of in irrigation definitely. And apart from that, apart from irrigation, when it is used into the corporate worlds or into the civic area, primarily, this has many more applications. Like it can create a microgrid basically, for a cold storage purpose, where you need around 40 to 50 kilowatt of power for chiller. So when you need a 40, 50 kilowatt or 100 kilowatt of power for chilling, achieving a temperature in the cold storage, you can install 5 or 6 or 10 of the solar tree in that area and create a microgrid, which will actually, or maybe integrated wind and solar tree, which can give you additional support and additional assurance of the power. And either it can be used independently by independent solar tree, or it can be grid integrated with the grid, so that grid power is used and solar power is able to reduce the power consumption. In a remote area where you don't have a grid, like in a very remote area where you don't have the government supplies or grid power, solar and wind combination is the best possible option. Like in the communication tower, many of them have already started asking, can the solar tree feed their 10 kilowatt requirement or 8 kilowatt requirement for a telecom tower? Because telecom towers are normally run these days by generators and other things. Some of them have installed the traditional solar system. So the diesels are stolen. Generators have a maintenance problem. In the remote area, the technician reaches after a week, so the communication is affected and transmission is affected. So the solar tree can actually, or hybrid wind solar tree can actually give them that assurance of non-stop power supply. Am I able to answer your question?
Yes, sir. Sir, is your air water generator capable of supporting drip irrigation, or is it best suited for drinking and livestock needs?
It is a multi-purpose system. See, again, when you are using it for a drinking purpose, possibly the cost of water producing could be little higher, 15 to 20% higher than the water being produced for irrigation purpose. Because when you are producing it for a drinking purpose, you need to add on certain uh, a certain system in the water filtration to make it suitable hard, keeping your hardness and TDS level less than 200, so that it is suitable to drink. But then for irrigation purpose, even your TDS is 400, 350, you can still use it. So the 15-20% cost difference in potable water, but then it is equally useful for drip irrigation, equally useful for your vertical farming, and it can also be used for the cattle's feed purpose. So it is an all-round system used for different requirement.
Okay. What are the cost benefit ratio of installing this system on small to medium sized farms? Do you offer modular or scalable solutions?
Yes, of course. So our most of the systems are modular system. At this stage, the system which we have designed for 1,000 liter per day capacity, actually is a modular system in 7 feet by 4 feet size. So it can be accommodated in a 8 feet by 5 feet platform, which can be taken in any trailer or any container or any truck anywhere. And it is, and then we also have the wheel mounted system, so it can also be carried to any desired locations in the farmhouse, in the small farms or in the large farms, or in places where they want to use. So it is definitely a modular system, and definitely cost advantage. Possibly you are if you compare with the bottled water, each of the mineral water or the filter water cost you around 10 to 12 rupees in a bottle. But then if you see that railway station has a 5 rupees liter water distribution system. So they are actually having an RO system within the system, within railway station, and they are offering, if you are bringing your own bottle, you are charged only 5 rupees. And if you buy a bottle from them, you charge 10 rupees per liter. Here we are trying to keep the cost of water at rupees maximum at 1 rupees per liter. So if you are able to produce water at 1 rupees per liter, I think the stations, public places can get this water at the most 2 to 3 rupees per liter, which is still half of the current offer by the railway stations and bus stations. No? So that will be having a lot of advantage when we are actually able to commercialize this at a multiple locations.
Okay. Sir, what is the approximate initial investment and payback period for farmers adopting a small solar tree?
Okay, solar tree adaptation is easier because government has a subsidy in that. Already 30% subsidy or 40% subsidy in different locations are available in different states. So a cost of a 3 kilowatt solar tree, possibly, see, a farmer will need around at least 3 kilowatt motor, generally they run. So they will need around 5 kilowatt system is the best suited for the farmer requirement. A 4 to 5 kilowatt system cost, actual cost, design cost and fabrication cost is actually close to uh, I'll say 1.8 lakh rupees, but with the sales of subsidy and all, it is actually close to 1 lakh rupees. 1 lakh rupees, you can get about 4 kilowatt of system after subsidy. And these days, the solar system also having a finance available from the banks and other places. So solar system can also be financed from the bank, and the farmers have that advantage. Basically they can also take the kisan credit loans and all for this type of system, which is also having a subsidy into them, and that's a very low interest rate. So this is very good possibility to adopt by the farmer who can actually from the very little investment, they can actually install one system, and actually they can lease out to the neighboring farmers, so that their cost is recovered. I will say within 1 year, I will say their cost is recovered. But most of the time, solar is not, payback is not less than 3 to 4 years. But when you are actually having one system and leasing out to 4 or 5 farmer or 6 farmer neighboring farmers, your payback is much faster. So assuming I put up a 10 kilowatt system in one of the farm, I should be able to feed, I should be able to support at least 8 to 10 farmers, every day. Because I will not run my solar pumps non-stop for 24 hours, maybe 2 to 3 hours maximum. So when I have a power available for 10 kilowatt, I will be able to offer the same power to the neighboring farmers, who will possibly use for 1 hour or 2 hour and pay on an hour basis. And that system is actually used in some of the European country, and not for the farming purpose, but they are using it for the for the urban power purpose. Suppose I am living in a society of 3,000 house, and 100 houses are unoccupied, or people are traveling or not using. So those 100 houses are able to sell their power when they are not available to at a lower rate, to the neighboring people. So the neighboring people get benefited of the lower rates of the power, and that's how the power is being distributed and power is being used on a house to house level. This is not yet available in India. The concept is not yet available in India, or not applicable in India, but several of the European countries are already have started using this type of sharing power mode.
Okay. What are the typical maintenance requirements and lifespan of these systems in rural and semi-arid settings?
See, the cleaning is the only thing required in solar tree, cleaning of the solar module, and which is covered by the sprinkler system. Once in a month or once in 2 months, maybe if we have a ladder system available, somebody can actually just go and check it manually as well, once in 2 to 3 months. But day-to-day cleaning is not required in this anyway. But possibly once in a week, cleaning for 15-20 minutes, maybe half an hour is good enough, and that needs around 40 to 50 liters of water. So it's not a very difficult maintenance things, because there is no other moving parts. Definitely, if unless we have a sun tracker. If we have a sun tracker, then another 10% cost increases, but then you have an additional 10 to 15% power. But even if you have a traditional solar tree without having sun tracker, uh, cleaning is the only maintenance basically, which can be done by any of the person. You don't need a specialized person for that, and there are cleaning by water is good enough in an open space.
Okay. Have you implemented any pilot projects in Gujarat or other drought-prone regions? What feedback have you received from the farmers?
So solar tree we have installed to almost 50 numbers in last 5-6 years. Every year we install around 8 to 10 solar tree actually in different locations. Like in Smart City Bareilly, we have installed 6 of them of 5 kilowatt each, with several features integrated in CCTV, gadget charging, music system, water sprinkler. So all these things are already integrated in that, and there are seating arrangement around the tree, solar tree. So people in the morning come and sit there and enjoy their walk and rest there. Apart from that, we have installed to the 5 of the Unilever factories in Assam and Punjab and Kolkata, then into the Punjab, and then to one in Sumerpur in UP. So there are different locations we have installed the solar tree for factories. Also, we have installed solar tree. First one was installed into the Army headquarters in Secunderabad in 2015-16, and so we have good feedback. We had failures in the beginning. No, there is nothing wrong in that, because when you are developing a product, it will not give you the desired results in the first instance. So we had a struggle in the first year. We had some failure, in a structure failure because the wind velocities, no, the systems were designed with the wind velocity, but then when you have a gust velocity, which is double of the wind velocity, your system fails many times. But then after that, we have started designing with the gust velocity, which is very rare to fail. Gust velocity is almost something which is a momentary velocity for 5 seconds, 10 seconds, but then it has double of the wind velocity speed. So when you are designing with a gust velocity, then failure of the structure is very, very, very rare. And apart from that, feedback power generation, of course, will vary depending on the region. Like people in the North India will have less power because in the winter there is a lot of fog and a lot of less sunny days. So they only get around 250 days. People in the Western India like Gujarat, Rajasthan, and Andhra and other places in South, they get close to 320 days of exposure, sun exposure. So their generation in those regions are much higher. Definitely 30, about 25 to 30% higher than the northern part of the India. So that's the difference,
Okay.
and that's a environmental difference.
Okay. What advice would you give to young engineers or agri entrepreneurs who wish to innovate in the clean energy agriculture intersections?
I personally feel the anyone who is trying to embark into the tech farming, they should definitely use this because it will reduce their overall cost of operation. As they will be using blowers and they will be using sprinklers, they will be using motor-driven systems and several of the polyhouses. So they should definitely go for renewable energy-based systems. There's also a vertical axis wind turbines we have designed now. So vertical axis wind turbines, which I showed in one of the solar tree integrated, that can also be a very useful product for the agriculture purpose as it has 24/7 power generation possibility. So that's something which is highly useful. Again, the traditional farmers definitely can also use this solar tree and air water generator because water is, they should not depend on the rain god all the time. So if we have capacity to produce 5,000 liters water, you put 4 or 5 of those systems, you have around 25,000 liters per day of water produced. It can be stored into the storage tanks and can be used for the drip irrigation or for the traditional irrigation if required. So both the concepts, both the products are quite useful for agriculture point of view, whether it is traditional farming or it is a tech farming.
Okay. Thank you, Meredith, sir. We have now completed the round of questions on behalf of agricultureinformation.com. We like to thank Mr. Ajay Kumar for the talk and for answering the questions. This meeting will now be closed.
Thank you. Thank you so much. Thank you for me.
Most welcome, sir. Bye-bye.
Bye-bye.